Now that's the final part of the tutorial when we will finally see the model. But before that, we like to look at the very small model to check everything we found and to find out how do we build faces from vertices. These are 4 parts of this very small model, some kind of shield. Let's open and see what's inside. Vertices part, precisely vertex indices. We have 74 bytes in hex, that will be by 4 bytes 1D, vertices 29 vertices. Now UVs will be 1 pair of UVs for each vertex. So 8 bytes normal, UV, index, total number of bytes E9, E8. E8 by 8 bytes, 1D again. So each vertex will have 1 pair of UVs and 1 normal, for sure. Now before looking into faces part, we'd like to check our main part of the model. Now we have 48 here as first byte, first number. And we had C8 in a big model. Now this can mean that this is some kind of flags for a file, which will probably tell us which parts this model will have. Like, remember we had CD boxes in the end of that big model, which can be collision data boxes. There are also CD spheres, and that means collision data probably has some boxes, some spheres, maybe something else. Now we don't have this here, so that probably indicates that 48 has 1 more bit set, and that means we don't have collision data here. So the bounding box of the whole model, that's it. This will be probably collision data for the whole model. And to zeros, and we have only 1 submesh here called like that, and the name E, that's a type of a highest load, and that's a bounding box, and 1 material for submesh number 1, 1 material again. It's only 1 load, and that's the name of that load. It has only 1 bone, called like this, parent, FFFF, as usual. Like X, Y, Z, they're all zeros, 0 rotation matrix. And now 1 connection, we had connections between bones and submeshes with this submesh to bone number 0. And now materials, this is 1 material. We don't have count, remember? 1 material of type 2 for the submesh, material number 0 for submesh number 1, and inside of a load E, highest load. And this 2 is what we have for a big table. We had either 2 or 6 here. We don't know what this is yet. A bounding box for that, and 2D faces, 1D vertices, which is 29. And then we had, after all these materials part, we have 3 magic numbers, like we have them big for a big model. That file we had 8CA records in 10 bytes table, 29 records in some other table, and that many indices. Now in this very small model, we have only 1A records in 10 bytes table, 0, that means only 1 record in that 40 bytes table, which is short, only 1 record. And again, 1A records in indices table in the end of faces part. Now we can check against the actual indices faces part what we have there. Let's open faces part. Okay, we are supposed to have 2D elements here in a table of face indices. And 2D by 2 bytes each, we must have 5A bytes here. That's it. This can be faces. This is 0, 1, 2, 3. They increase, and that's the end of that. Then we are supposed to have 1A records in a table 10 bytes each. 1A by A, 104 in hex, 104. That's the 10 bytes table. Like each record in that will be 10 bytes. Now we're supposed to have one entry in 40 bytes table. 40 bytes. Here, 40 bytes. That's it. As usual, it has some zeros, a bounding box, 1A again. What's this? That's the same 1A like here. And in the end, we have some number of indices. We must have 1A indices, 1A by 4. This will be 68. Must be 68. It's 68. Okay, so all our numbers here correspond to our faces part. Now the only thing we need is to build faces from these face indices. Like usually in modern games, we have normal face indices, and they go like that. 3 indices form a triangle. This will be a face. Vertices number 0, 1, and 2. That's the first face. Now vertices number 3, 4, and 5 connected. They form face number 2. Now we have something strange here. 6, 6, and 7. This will not be a face. Like this will be just a line connecting vertices 6 and 7. And the same thing in the next one. And moreover, in a big model, we have this count not divisible by 3. And that means, unfortunately, this is not normal face indices. This part is something else. However, it looks very similar to face indices, but that's not it. So probably we now check that 10 bytes table. I saved it here. Now what we see here, we had in 10 bytes there are 5 small numbers. 3 numbers were a bit bigger than others, and now in this small model we have only 1 here, all zeros here, and some numbers here. So let's say maybe this is our face indices table. And we can actually build faces for the whole model from this. So let's try exporting them in a geometry file and load that into Blender. Okay. It may look like some kind of a shield. These are all faces, triangles here. Not many vertices, but that's it. That's probably a proper mesh that we're supposed to have here as our shield. Okay, let's close that. So these are actually faces. Then what's this? There is actually an old type of the structure called triangle strips. In this, triangles will be built like 0, 1, 2, then 3, 2, 1 in backwards direction, then 2, 3, 4, 5, 4, 3. This is like triangle strip works. 2 vertices used in a phase will also be used in the next phase. This must make a list of indices shorter, but this leads to things like this. We need to repeat 777 to make phases we need. And they always change direction. This one will be forward, that will be backward. And if we check this, 0, 1, 2, 0, 1, 2. Now next phase is 3, 2, 1, 3, 2, 1. And the last one will be 11, 1CF, 11, 1CF, and before that, 1C, 11, 1B, 1C, 11, 1B in opposite direction. That means that is actually a triangle strip that totally corresponds to this normal phase indices table. So this very small model has only one load, and it's presented both like triangle strip and normal phase indices. We build that, we check that. This is some kind of a shield. Now we probably know everything we need to build the big model of our vehicle. So let's close all that and go to our big model files, AMS, the faces of it. This in the beginning of file, this will be triangle strips then. And the next part, which I called 10 bytes table, this will be normal phase indices. And we have a table of everything saved here. So, like we've seen that in that small model, in this table of materials, this first number is not a number of faces, this is a number of elements in the triangle strip. And this actually is a number of vertices. Used both for triangle strip and for normal phase indices, this is a number of vertices in every little part of the model. So we can say we don't have any offsets in the vertices table. But how do we build this? The very first part of the very first load here has 6 elements in a triangle strip connecting 4 vertices. These indices will only index 4 vertices. Now next part, 8 vertices. So if we want to build the highest load, which is probably what we need, this E, we need to skip all these vertices before that in vertices part and start from this first one, which will use 351 vertex connected as triangle strip, or better, we better build them using that 10 bytes table, like normal phases, because it's more convenient for modern programs. Oh, and now we can see probably these 2 and 6. We have only one question left. How do we detect how many UV pairs we have? Let's check this. Probably we'll have that many with 2 and that many with 6. So if we check the UVs part, we'll have about that with 1 pair of UVs. This will be about 40, probably that. And then start a part with 2 pairs of UVs each vertex. Then probably this 2 is 1 pair of UVs and 6 is 2 pair of UVs. We can try that and see if it works. So we need to build a model from these submeshes. Let's open the 10 bytes table for that. And it starts with, these are phase indices. Okay, and this number is 12. When we scroll down, it's 4. 3. It looks like they go in the order of this table, like 12, 4, 3E. And these all have 4 must have 2 materials. And inside of these 4, first we have 0 and then we have 1. Like this is inside of submesh 4. First we go with material number 0, material 1. Material 0, material 1. And if we scroll down to that main submesh, that's supposed to have 8 materials. 1. Yeah, it looks like you have material 0, 1, 2, a big material, 3, 4, 5, 6, 7, which is 8th material. But we can see here they are in different order. Then we have material 7, 6, 3, 2, and here we go like 0, 1, 2, 3, until 7. That's strange. What do we choose? Let's try first loading them in an order like they were in 10 bytes table. Well, it looks wrong. Like we have proper wheels because we have only one material, and this main part is all messed up because probably the order of materials inside of the submesh is wrong. So it means that we must go in the order of, in this order of this table. Like first these 6 vertices will belong to material number 7, and they will be indexed for this one. Then material number 6 with 53 vertices indexed by this chair material. And then we go to a last part. So let's try this one. Okay, now it works, and we finally see a proper model of our vehicle. We can see a steering wheel there, all doors and wheels and even suspensions. They are all in different colors because they are saved and as different materials and different submeshes. We have a list of these submeshes here. We can select them separately, and we can check the UVs for them. That's one of the wheels, the UVs for it, side part, and this part is repeating. Now let's go to, this is the cabin part, UVs for it. What's this? This is the windshield, UVs for it. And I have also a skeleton loaded. That's our skeleton. The bones for all wheels and suspensions here. Lights, doors, steering wheel bone. This is deploy point. And all other bones. They all look correct. Okay. Now, we have still one table unidentified. This 40 bytes table with 29 rows in this big model. What can this be? We can open it again. That's that big table. And remember we had some biggest number here. They go from, sometimes they are 0, and they go increase and increase and increase until ACD. These are bounding boxes, 6 floats, and we can see when this is a 0 here, we have 2 numbers, and if we have 1 here, we have some number and some other number. This is a record. it goes from here to here. So we have 1DD and this 96D. And if we add that plus DD, we'll have A for a next entry. And if we took our last one, ACDE plus F2 here, this will be BBF. And this BBF is the number of indices here. These are indices in the last part of this section. So this is probably offsets inside of this indices table. And this is the number of indices in one part of this table. And these indices, as we found in the very second part of the tutorial, they are indices into the 10 bytes table, which we know is now a table of faces. So this big table, unknown table, has probably it's dividing the whole model by some groups of faces. These faces will not correspond to materials or submeshes because we can see they go from 0 to 6 something and again from 0. So the first part will just take some faces from a cabin, some faces from front wheels or something, probably. This can be damage data. Like if you hit the vehicle into a front part, like these faces will be damaged, maybe. And this records with 34 in the beginning and no number here and 2 numbers here. I don't know what this is, but I'm sure if I look for this somewhere, maybe in different files, I can probably know what this is and what it's for. Maybe build these bounding boxes, visualize them, and see where they are located, and then we can know what is it for. Now this is how one by one we can identify parts of the model files and find what's inside, measure them, count them, find this count somewhere, and identify everything else, like solving a puzzle.